All right, guys. My concept guide says 8.5. Yours is 10.4. No big deal. Same concept guide. All right, so we'll roll through this. Remember that you can pause it at any point. So no matter what speed I'm going, you can rewind it and you can pause it and watch it from there. Liam, Donald, please be on your best behavior. Sorry for lumping you in with him, Liam. So after you're done with this concept guide, you'll have a worksheet. All right, work it, do the best you can, and we'll go from there. So a hyperbola is the set of all points in a plane such that the distance or difference of the distances from any point on the hyperbola to any two given points called foci in the plane is constant. A hyperbola has two vertices. The distance from the center to each vertex is a units. A hyperbola has two foci. The distance from the center to each focus is c units. And a hyperbola has two axes of symmetry. Unlike ellipses, has nothing to do with A and B. All right, the transverse axis is a segment length of 2a, whose endpoints are the vertices, okay? The vertices are where our hyperbolas start from, and they expand out. The conjugate axis is a segment length of 2b. A hyperbola has two diagonal asymptotes that the graph approaches but does not touch. The asymptotes are what give us the shape of our hyperbolas, how big, wide, skinny they are. Then A, B, and C are related. C squared equals A squared plus B squared, or C equals square root of A squared plus B squared. All right, C is for the foci. Again, we are not doing foci, so don't worry about that. All right, I'm gonna play. All right, so what's different than ellipses is it does matter in hyperbolas whether the x or y comes first, okay? If x squared comes first, like this example below, it is a horizontal hyperbola. All right, if you look at that black line that goes from vertex to vertex, that is the transverse axis. That green line is the conjugate axis. That red box, we draw that to get our asymptotes. The blue line is our asymptotes that goes through those corners. All right, so as you can see, so good, I marked this here. Vertical hyperbola is flipped. Okay, going the other direction. So when it's flipped, so is the transverse and conjugate axis. All right, it's important that on a vertical hyperbola, y comes first. You got y squared that comes first. Everything's labeled. This is a good point right here to pause and make sure you mark this all down correctly, okay? All right, so this example is a horizontal ellipse right here. This first example, I know it's horizontal because it's x squared over 9 first. My center is at 0, 0. Okay, it's because it's just like circles or ellipses, it's x minus h squared, y minus k squared. So if there's no numbers there in the numerator, the center is 0, 0. All right. So I get my vertices from a squared, which in this case, a squared is 9. Again, another difference from ellipses is hyperbolas. A squared can be smaller than b squared. That's fine. That does not matter. Okay? So in this case, a squared is 9. A squared comes first, always, in hyperbolas. So that means a equals 3. So from my center, I'll go right 3 and left 3, which would be the points 3, 0, and negative 3, 0. All right. That is where my hyperbolas will start from. But I have to do my conjugate axis and draw my box to get my asymptotes. So next, I have b squared, which is 16. So that means b is 4. Square root of 16 is 4. All right, so my conjugate axis is at 0, 4, and 0, negative 4. The conjugate axis is only important because it gives us our box that we're going to use to draw our asymptotes. Okay, so I draw my box. All right, from my center, I'm going to draw my asymptotes going through each corner of the box. All right, from there, I'll draw my hyperbolas. They will approach my asymptotes, but they will not touch. So on this example, I did the foci. We're not doing foci. If you do the foci, I'll give you extra credit. Okay, that's up to you. So the foci would be at 5, 0, negative 5, 0. Okay. All right, next example is a vertical hyperbola. I know that it's a vertical hyperbola because y comes first. Okay, y comes first. Y squared over 4. That's telling me it is a vertical hyperbola. Again, the center is at 0, 0. All right, so my transverse axis, get it from a squared, which is 4. Transverse axis, always get that from what comes first. A squared is always first. So a is 2. Now, since this is a vertical hyperbola, my vertices will be at 0, 2, and 0, negative 2. All right, next, I do my conjugate axis. Again, the only reason I need my conjugate axis is to get the box, which gives me the proper shape of my asymptotes. Okay, so b squared is 1, so that means b is 1. So from my center, I will go right 1, left 1, or 1, 0, negative 1, 0. So I'll have my tiny little box. My asymptotes will go through each corner, and my hyperbolas will start at my vertices, approach the asymptotes, but they will not touch. All right, I'm sure that I did the foci here. Yep, I did. So in this case, the foci would be at 0, 2.25, 0, negative 2.25. All right, which is just past the vertices. Again, the foci is always coordinated with your vertices, okay? That's why it would be up from the y right here, okay? All right, again, you can rewatch this, go back, you can pause it, all right? Not trying to be too fast on you. All right, some examples. All right, we're writing an equation for the hyperbola with what's given. All right, well, because my vertices are at 7, 0, and negative 7, 0, if you looked at that on the graph, that would be on the x-axis, right? I know that this is going to be a horizontal hyperbola, okay? This will be a horizontal hyperbola. That's telling me that a is 7. 2a, which is the entire length, would be 14. So a squared would be 49. Then my conjugate axis length, the entire length of my conjugate axis is 10. So that means 2b is 10. All right, so that means b is 5. So b squared is 25. With that given there, I can now write my equation for the hyperbola, okay? That'll give me x squared over 49 minus y squared over 25 equals 1. All right, again, I know that x squared comes first and that it's a horizontal hyperbola because my vertices were at negative 7, 0 and 7, 0. Whereas if you look at the next problem, number 2, I know my hyperbola is going to be vertical, and y squared will come first because my vertices are at 0, 8, 0, negative 8. That is on the y-axis, going up and down from 0. Again, so I know a is 8, so a squared is 64. All right, I changed the conjugate axis length to 4 here, so I get a better number. All right, so that, remember, the conjugate axis length, that's the entire length of it, is 2b. So 2b is 4. So b is 2, so b squared is 4. So I have y squared over 64 minus x squared over 4 equals 1. Next, I have my vertices at 1, 0, negative 1, 0. Okay. So, Andrew, what kind of hyperbola is this? Horizontal. Good job, Andrew. All right, so again, I changed my conjugate axis length to make it a better number, not a fraction or decimal in these examples. All right, so a equals 1, so a squared is 1. 2b equals 8, the entire length 2b equals 8, so b is 4. So b squared is 16. So my equation for the hyperbola would be x squared over 1 minus y squared over 16 equals 1. All right, next section. All right, x squared over 4 minus y squared over 9 equals 1. All right, is this going to be vertical or horizontal? Good job, Donald. It's horizontal. X squared comes first. So a squared is 4, b squared is 9. So that means a equals 2. So that means my vertices are at 2, 0, negative 2, 0. B equals 3. So that means my conjugate axis is from 0, 3 to 0, negative 3. Remember, that just helps us get our box. That's all we're using it for. I have my box. Now I can do my asymptotes through the corner. And my hyperbolas will approach the asymptotes, but will not touch. Okay. Ooh, I did the foci here as well. I probably did it on all of them. All right, again, if you want to do it for extra credit, you can. As you can see, they're with the vertices. So they were at 0 or 3.6 comma 0 and negative 3.6 comma 0. 5. All right. That didn't mean to do that. All right. So as you can see, my vertices were at 0, 3 and 0, negative 3 because y squared came first, so I knew it was vertical. All right, so mark that down. My conjugate axis comes from b squared, which was 4, so b is 2. And get my conjugate axis there. And I have my hyperbolas. All right, if you really want to go the extra mile, try and do 16 by yourself. Or try and do number 6 by yourself. And then look up the answer next, okay? All right. This is what you should have gotten, okay? If at this point you are confused, feel free to ask someone in your class. All right, work together. All right, I feel like y'all should get this. This isn't too bad. All right, we got one last question. We're given the hyperbola, right? We're given the hyperbola. Now I need to write my equation with what's given. Well, my vertices are easy. I know it's going to be horizontal. I can see my hyperbolas. My vertices are on the x-axis, so x squared comes first. I can also count and see that my vertices are at 3, 0 and negative 3, 0, so that means a is 3, so a squared is 9. So to get b squared, my conjugate axis, all right, I'm going to draw a box. I'm going to start at my vertex, either vertex, and draw a line going up to my asymptote. Then I'll draw another line going across. Oh, another one went up, my bad. Another one down, another one down. Now I've driven lines to all my asymptotes. I'm now going to connect them. All right, so now they are connected, and I can see that my conjugate axis is at 0, 3, and 0, negative 3. So b is 3 as well. So b squared is 9. And you have your equation for the hyperbola. All right, so next step, you'll have a homework sheet on this. I'm sure y'all will get it, do the best you can, and I will see y'all on Tuesday.